Hello viewers, in this video I would like to discuss Newton-Raphson method, formula and its derivation and some deductions. What is the objective of Newton-Raphson method? Newton-Raphson method is an iterative method for finding the roots of an algebraic and transcendental equations, that is fx is equal to 0, where fx is a function of one variable x and it is same as we took in the bisection method as well as in Regula-Folcy method. Newton-Raphson method is also known as method of tangent. To start the iterations, it needs an initial or a starting value. Convergence or divergence of the method or result depends on the initial or starting value. Selection of initial value, that is x0. So 0 represents we find the interval in which function changes its sign and can take the midpoint of the interval as initial value. Now let us derive the Newton-Raphson method. Let x1 is equal to x0 plus h be the exact value or the better approximation of the root, h being a small quantity. Then fx0 plus h is equal to 0. It means x0 plus h, which is the exact or better approximation, will satisfy the equation. So once we put x0 plus h in the equation, it should be equal to 0. Expanding fx0 plus h by Taylor's theorem, we can have fx0 plus h is equal to fx0 plus hf dash x0 plus h square upon factorial 2 f double dash x0 and so on is equal to 0. Neglecting higher order terms, we get first two terms of right hand side, and these are fx0 plus hf dash x0 is equal to 0. From here we can find out value of h, which becomes h is equal to minus fx0 upon f dash x0, provided f dash x0 is not equal to 0. Now we substitute this value of h in x1 is equal to x0 plus h, and we get this expression, that is x0 minus fx0 upon f dash x0. This is the next better approximation. So x1 is the next better approximation of the root of the equation fx is equal to 0, then x0. Since x1 is not an exact root of the equation fx is equal to 0, therefore we perform another iteration to find the next better root. To get x2, the value of x0 is replaced by x1 in the formula. Therefore x2 becomes x1 plus h, which is equal to x1 minus fx1 upon f dash x1. And n plus 1th iteration also we can write down, and that becomes, so this is xn plus 1 is equal to xn plus h, which is equal to xn minus fxn upon f dash xn. So these values have been calculated on nth root, and we are calculating n plus 1th root. N takes values 0, 1, 2 and so on. We will terminate the iterations when the absolute value of the difference between two consecutive approximate roots is less than or equal to error tolerance, that is xn plus 1 minus xn mod is less than equal to epsilon. This may be prescribed wherever we are applying Newton-Raphson method or requirement according to the situation, and this mod xn plus 1 minus xn should be less than equal to epsilon, where epsilon is the error tolerance. Error is a pre-assigned value, very small positive number based on desired accuracy. Now there are a few deductions also of Newton-Raphson formula. So we see what are those deductions. So there are four deduction formulas here, for 1 upon n, for under root n, 1 upon under root n, kth root of n, and these are in general form. So xn plus 1 is equal to xn 2 minus nxn. This is for 1 upon n. For under root n, this is the formula. For 1 upon root n, this is the formula, and for kth root of n, this is the formula. So these are the formulas which are the deductions from Newton-Raphson method. Thank you.